Next, we try to find the equivalent circuit seen from the load. According to the same equation, we need to eliminate I1 so we can get it's also a form of Ohm's law. The numerator is the voltage source and the denominator is the impedance connecting to the voltage source, and the impedance can be divided into two parts, that is the original secondary impedance part of Z22 and the impedance introduced from the primary impedance due to the mutual inductance of the transformer. Thus we can draw such an equivalent circuit, where Z22 is the total impedance of the secondary side. The reflected voltage source is the reflected impedance is. It should be noted that the two equivalent circuits seen from the primary and the secondary sides have practical application values for solving the air core transformer circuit. You can try to use the two equivalent circuits for different problems. In addition, we can also use the decoupling equivalence of the mutual inductance coils taught in Lecture 80. That is, for the two electrical isolated circuits, we can connect them with a line without any change of the branch variables. Then we can get its decoupling equivalent circuit, that is, we can analyze the branch variables of the whole circuit by decoupling equivalent circuit. Similarly, we can find its equivalent circuit seen from the source and the load respectively. It should be noted that such a decoupling equivalent circuit is the main circuit for analyzing transformer in the electric machine saw course. After finished the analysis of the transformer, let's do an exercise. The effective value of the power source is 20 volts and its internal resistance is 10 ohm. The impedance of the load is 0.2 minus J9.8 ohm, which is the capacitive impedance. Obviously, the load impedance and the source impedance are not conjugate match, so we need to design an energy processing circuit so as to obtain the maximum power for the load. The problem requires us to design a lossless air core transformer. That is, R1 and R2 are 0 in previous model of the transformer. The transformer includes L1, L2, and M only. Before watching the following video, you can analyze how to set L1, L2, and M in order to transmit the maximum power. Let's have a look. This is the air core transformer whose primary reactance is 10 ohm and the secondary reactance is 10 ohm. The mutual inductive reactance of them is 2 ohm. Now we analyze such a circuit. We analyze it by the equivalent impedance seen from the source, that is, here Z22 equals J10 plus 0.2 minus J9.8, that is. So the reflected impedance is, for such a transformer, the primary impedance is, we can find that in such an equivalent circuit, Z11 and ZL are conjugate match, and ZL obtains the maximum active power generated by the power supply. Then we analyze where did the power in the equivalent reflected resistance of 10 ohm go. Because the air core transformer we introduced is lossless, that is, 2J10 and 1J2 would not consume active power, so all the active power can only be consumed on the resistance of 0.2 ohm. It means that the 10 ohm seen from the source is the actual load of 0.2 ohm. Thus, we know that after introducing such an air core transformer, the maximum power obtained by the load is So we finished the analysis of the problem. Do you find the air core transformer can realize the impedance matching? Well, that's the end of this lecture.